Hi guys, this is going to be the first part of learning how to graph sine and cosine. So let's skip over this first slide. On this slide, we're going to briefly recall the unit circle and some values that are important. Okay, so this in radians was 0 and 2 pi. Okay? This was pi over 2. This was pi, and this is 3 pi over 2. Okay, so let's talk about some values for sine. Okay, so sine, remember, was y over r. So sine of 0, okay, if you think about this ordered pair, is the ordered pair 1 comma 0. So sine y over r, where r is always 1, is just going to be 0. Same thing for 2 pi also. So this is the ordered pair 0 comma 1. So y over r, sine of this theta being pi over 2 would just be 1. This is the point -1 comma 0. So for sine of this value of theta, we would also get 0. This is 0, -1. So here, sine of this theta would be -1. Nice things to remember as we go through this. Okay, so a word you're going to hear a lot in the coming weeks is going to be your period. Okay, it's the interval in which a periodic function goes through one cycle. So when I say periodic function, that means a function that repeats itself, basically. Okay, so we're going to graph one full cycle of these. We're not going to keep graphing because it keeps repeating itself forever and ever. Okay? So for the normal sine graph with no changes to it, and in a lot of these, we're going to use some transformations that you saw in Algebra 2. So like vertical and horizontal shifts and stuff like that. Okay, so for this guy, the period of the normal sine graph is simply 2 pi. So it repeats itself, and you can see that up here, right? It goes from 0 to 1 to 0 to -1 to 0, and then it repeats itself again, right? If you would keep going. So the period of regular sine graph is 2 pi. Now, what we're going to graph these is we're going to break them into quarters, okay? And you'll see me abbreviate quarters with just a QS, okay? So to find how you break these graphs up, you're going to break them up into 4 sections here, hence quarters. You're going to take your period divided by 4. Your period's not always going to be 2 pi, okay? But in the normal sine, without anything done to it, it is 2 pi. So in this case, if we take 2 pi divided by 4 and reduce that, we get pi over 2. What we're going to do from there is we're going to get some x and y values to help us graph this. So the quarters tell us how we're going to count. So for this guy, we're going to start at 0. And in the coming notes videos, you're going to see that we won't always start at 0. But for now, we're going to start at 0, and we're going to count by pi over 2. So if we add pi over 2 onto 0, we get pi over 2. Add on another pi over 2, and we get pi. Add on another pi over 2, we get 3 pi over 2. Add on another pi over 2, and we get to 2 pi. Okay? So we broke this up, and we counted by our quarter here, this pi over 2. Now, we saw before that the y values that go with this. So let me zoom out here a little bit. So when we're at 0, okay, our y value for our sine graph was 0. When we're at pi over 2, the value that we got out is 1. Okay, when we're at pi, the value we got out is 0. 3 pi over 2, we got out -1. And at 2 pi, we got out 0 again. So we're treating these, our theta or our inputs, as the x's, and what we got out of the function as our y's. So the theta here is the x that we're talking about down here, and the output that we got out from that equation is the y value. Okay? And remember this pattern for sine. This is going to be important. The fact that we start with 0, we go 0, 1, 0, -1, 0. Okay? So if we come over here and we plot this, so I'm going to break this up into my quarters and try and pay attention to your scale as you go. Okay, so this is clearly 0, pi over 2, pi, 3 pi over 2, 2 pi. So if you're making this pi over 2, make sure that you're making it the same increment as you go along. The highest value we had is 1, the lowest is -1. So let's plot these points then. 0, 0, pi over 2 is up at 1, pi is at 0, 3 pi over 2 is at -1, and then back up. And don't connect these real rigidly. They're actually, if you would graph them, they're really smooth curves. Right? If you would get more in between values, you see that they form nice smooth curves. And if you would go beyond this, it would just keep repeating. Same thing this way. It would just keep repeating it. All right, let's talk about the domain and range. So the domain, we can put in anything that we want for this. Okay, any value. I mean, I just did some nice values, but you could put in any decimal, anything at all. So the domain is actually negative infinity to infinity for all reals. But the range, however, the smallest value you're always going to get out, and think back to the last chapter how we said that sine is opposite over hypotenuse technically, we're always going to be between -1 and 1, including those, hence the brackets. Okay, now let's go back up here and let's talk about cosine values. Okay, so cosine, okay, so we know cosine, let's do theta, is x over r. Okay, so for cosine here, if we do x, which is 1, over r, which is 1, we get 1. Cosine of this theta, which is the pi over 2, we would get 0 over 1, so just 0. Here, x over r, we would get -1. Here, x over r, we get 0. And then back here, again, we would get 1. So now let's use this idea to see what the graph of cosine looks like. So same thing, we're going to split this up. The period, if there's nothing done to this, just your generic cosine, there's no other values here, it's just 2 pi. Okay, the quarters, take your period, same as before, divide it by 4. Okay, so it's your period divided by 4 still, and that's pi over 2. Now once again, the x value that I'm referring to would be the theta from above. So start at 0, count by your quarters, just like the last one. Now the values are different for the y here. By the output here, we got 1, 0, -1, 0, 1. So 1, 0, -1, 0, 1. Some people remember sine because it looks like YOLO in the beginning. So they remember that it's 0, 1, 0 because of that, and then -1, 0 again. And they always fit this kind of pattern, if you will. Okay? So if we graph this, so this is 0, pi over 2, pi, 3 pi over 2, pi. The largest is 1, smallest -1. And then plot these ordered pairs, 0, 1, a pi over 2, where it's 0, pi -1, 3 pi over 2, 0, and back up to 1. And once again, these are smooth curves. Don't look like this. Okay? And then if you kept going, it would keep following this pattern. Okay. So let's talk about an amplitude shift. This is probably, oh, sorry, I forgot to do the domain. Domain is the same for sine. You can put in anything you want. So all reals, negative infinity. And range is also the same, -1, 1, including those values. Okay, amplitude shift. So notice here in front of the sine, I have this a value. Okay, so that is your amplitude. Now your amplitude is technically the absolute value of a. I don't care if it's negative or not. I just want the number. So if it had a -2 out front, you would just tell me the amplitude is 2, not -2. And the amplitude is the height from the center line to the peak. And when you see this, we'll see what I'm talking about. Okay, so I'm going to do an example. So let's say y equals 4 sine of x. Okay, so now I'm going to add on to the list of items that we did before. I'm going to add on my amplitude. So your amplitude here is 4. Like I said, if it were a -4, you would still just say 4 for the amplitude. Your period is 2 pi. We haven't done anything that changes the period yet. When we get to that, you will know. Okay, your quarters, once again, it's your period divided by 4. So that would reduce to pi over 2, just like before. Now, let's talk about what's going to change with our chart. Okay, so these values are actually the same as before. So we're counting by the quarters. So go up pi over 2, go up pi over 2, add on pi over 2. Now, what's going to change here is I had said before, it's helpful to remember sine by thinking that it's kind of like YOLO in the beginning. 0, 1, 0, x, 1, 0. Okay? Now, I did them little up in the top right-hand corner. Let's think about this. This part, just the sine portion, came out to 0. Now you're taking that value times 4. So that's still 0. So now if the sine part alone came out to 1, now you're taking that times 4. Same thing here, but negative. Okay, so the sine portion, you would put in sine of pi over 2 and evaluate that. You would get 1 times 4 if you think about your order of operations. So let's take a look at this a little. So if I would set up my scale here, now be very careful. So the normal graph went from negative 1. I'm going to kind of do the normal graph in a dashed line so you can see what's going to happen here. Actually, just based off of how much room I have, I'm going to smaller because I need to go up in my other one. Okay. So normally it would start here, 0, we go to 1, 0. So this is normal sine graph. So now though, if it's 0, now pi over 2 is 4, back at 0, down at negative 4, back. This guy looks like this. So the amplitude is stretching your graph vertically. Okay, it's kind of pulling it out. Okay, so if you have a number out front, it's stretching the graph. Okay, now let's look at a vertical shift. So notice here I have a value added on. So C shifts the entire graph up or down C units. Okay, so let's look at an example. And like total side note, think about from number 2, like y equals x plus c. So if I had x plus 2, now they just have it added in the front. It doesn't matter. Move your graph. So it's going to do the same thing here. So let's look at an example that has a amplitude and a vertical shift. So let's do 3 plus y equals 3 plus 6 cosine x. So now we're going to add on to our list again. Okay, so the first thing we're going to talk about is that vertical shift. So the vertical shift is this 3. So it is up 3. If it were negative 3, it would be down 3. Okay, then the amplitude from before. So each time I'm adding on here. So the amplitude is this value that's right in front of the trig function. So 6. And even if it were a minus 6, you would just say 6. Okay, our period, once again, we haven't messed with that at all. So that stays 2 pi, which helps us find our quarters, which is our period divided by 4. So once again, our quarters are just pi. So now let's look at what our chart is. So all of these are staying the same because we haven't messed with that. We will get to that next week at some point. Okay, so now cosine, so sine was the YOLO, so cosine goes 1, 0, 1, 0, 1. Okay, remember those patterns. Notice I did it really small. That's going to help me figure out. So think about this. Cosine of 0, so just this part right here, okay, is 1. Think about order of operations. Take 1 times 6 plus 3. So this would be 9. Okay, cosine of 0, if I put 0 in the cosine, that comes, cosine of pi over 2, my bad. I put that in, I get out 0. Times 6 is still 0, plus 3. Okay, cosine of pi. If I put in pi here, I get out negative 1. Times 6 is negative 6, plus 3 is negative 3. Cosine of 3 pi over 2 is 0 times 6 plus 3. And then cosine of 1, I'm going to get periodic. So it goes back. So let's come over here and let's plot this. Sorry, I only have a minute left. So I'm going to rush through this. So the normal graph of cosine looks like this. Okay? So now this one, at 0, I'm up at 9. Clearly I didn't scale this very well. So I'm up at 9. Then I'm at 3. Sorry, I should totally scale this here. And then I'm back up at 3 and then back up. So this, not only do we have an amplitude that stretches by 6, and we and move up 3 as well. This center line here, which is normally on the x-axis, was moved up by 3. Okay? All right, you have a couple practices to do down here. I will post a key. My key will not have all the necessary work, but yours should. Please reach out if you have any questions. Have a good one, guys.